Hello class. Today we will be going over chapter 4, which is the numerical representation and calculation of numbers. In 4.1 we will go over our Hindu-Arabic systems and an early positional systems. Our objectives today are to evaluate an exponential expression, write a Hindu-Arabic numeral in expanded form, express a number's expanded form as a Hindu-Arabic numeral, understand and use Babylonian numeration systems, and to understand and use the Mayan numeration system. We'll first review our exponents. If n is a natural number, b to the nth is read the nth power of b, or b to the nth power. Thus, the nth power of b is defined as the product of n factors of b. The expression b to the nth is called an exponential expression. Furthermore, b to the first equals b. So if we look here at our example, b to the nth is just b multiplied n times. If we look at our exponents review here, we see that our first exponential expression here is 8 raised to the first power. 8 raised to the first power evaluated is just 8. Our second expression is 5 raised to the second power. 5 to the second power, or 5 squared, is just 5 times 5, which is 25. Now 6 raised to the third power, or 6 cubed, is 6 times 6 times 6, which is 216. So essentially, whatever that exponent is, that's just the number of times we're multiplying that base. So 10th to the fourth power is just 10 times 10 times 10 times 10, which is 10,000. And 2 to the fifth power is just 2 multiplied by itself 5 times, which is 32. Now our Hindu-Arabic numeration system is what we'll go over next. An important characteristic is that we can write the numeral for any number, large or small, using only 10 symbols called digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Hindu-Arabic numerals can be written in expanded form, in which the value of the digit in each position is made clear. We can write 663 in expanded form, such that 663 is 6 times 100 plus 6 times 10 plus 3 times 1. Or 6 times 10 squared plus 6 times 10 to the first plus 3 times 1. Our Hindu-Arabic system also enumerates into what is called a positional value or a place value system. The positional values in the system are based upon powers of 10, starting with 1. So we start with 1, and then we look at 10 to the first, which is 10, 10 squared, which is 100, 10 to the third, which is 1,000, 10 to the fourth, which is 10,000, 10 to the fifth, which is 100,000, and it continues on in that fashion. So if we look at another example here, we can write 3,407 in expanded form. By doing 3, we start from the left, we take the 3,000 and represent it as 3 times 10 to the third, because there are 3 spaces behind that particular number there. Then we can take the 4 and we can represent it by 4 times 10 to the second, because there's 2 positions behind the 4. We'll represent that 0 as 0 times 10 to the first, because there's 1 position behind it. And we will do 7 times 1 because it's in the ones place. Now we can write it with those exponents, or we can write it times the actual number, which the second case does: 3 times 1,000 plus 4 times 100 plus 0 times 10 plus 7 times 1. Now here we want to express the expanded form as a Hindu-Arabic numeral, essentially working backwards. So what we see here is 7 times 10 to the third plus 5 times 10 to the first plus 4 times 1. Now, if we're looking at this, we'll start by showing all the powers of 10, starting with the highest exponent given. Any power left out is expressed as 0 times that power of 10. So we have 7 times 10 to the third plus 5 times 10 to the first plus 4 times 1. As you can notice here, the tens place that's left out is that 10 squared's place. So that place is then there filled by a 0. So if we rewrite this, we get 7 times 10 to the 3, or 10 to the third. We didn't have a squared in here, so we know that that squared had to have been multiplied by a 0. So 0 times 10 squared. 5 times 10 to the first, just rewriting that, and 4 times 1, just rewriting that. Now we have all of our tens with our correct countdown exponents written here. And we can take this number and we can write it 7 in the thousands place, 0 in the hundreds place, 5 in the tens place, and 4 in the ones place. Now, let's look and see how the Babylonian numerical system, or numeration system, compares to our Hindu-Arabic system. The place values in the Babylonian system use the power of 60. The place values are 60 to the third, which is 60 times 60 times 60, which would be 216,000. 60 squared, which is 60 times 60, which is 3,600. 60 to the first, which is just 60, and 1. The Babylonians left a space to distinguish the various place values in a numeral from one another. So, we write the following Babylonian numeral here, that's represented by V's and carets, so to speak, as the following. So, if we look at our solution here, from the left to the right, the place values are 60 squared, 60 to the first, and 1. Okay? So, what we see here is that our representation, starting from the left and working to the right, are that the V's, essentially here, represent ones, and they're multiplied by 60 squared. The numeration here represents 10 plus 1, and the numeration here represents 2 tens plus a 1. So what we're seeing here is that these are a 1 representation, and the sideways V's, or the carets here, however you want to call them, are representing the tens. Okay. Once broken down, we can put it in our common Hindu-Arabic numeral here by simply solving it out. 1 plus 1 is 2 times the 60 squared. 10 plus 1 is 11 times the 60 to the first. And 10 plus 1 plus 1 is 22 times 1. Now, once we do this simple multiplication here, we see that 60 squared is 3,600, 60 to the first is just 60, and the 1 is just 1. We can multiply the 2 times the 3,600 and get 7,200, the 11 times 60 and get 660, and the 22 times 1 and get 22. Add those three together and we see that in the Hindu-Arabic system, this representation, written here as a whole, would actually be 7,882. Let's also look at the Mayan numeration system. In the Mayan numeration system, the characters are as follows. So you can see what looks almost like a coin underneath the 0. 1 dot for 1, 2 dots for 2, 3 dots for 4, a line for 5, a line plus a dot for 6, a line plus 2 dots for 7, a line plus 3 dots for 8, a line plus 4 dots for 9, 2 lines for 10, 2 lines and a dot for 11, and the pattern continues on. Essentially, each line represents a 5. Okay? And each dot represents an additional 1. The place values in the Mayan system are 18 times 20 raised to the third, 18 times 20 raised to the second, and 18 times 20, 20, and 1, where you can see the mathematical breakdown below in the blue. Numerals in the Mayan system are expressed vertically. The place value at the bottom of the column is 1. So, let us write this Mayan symbol as a Hindu-Arabic numeral. So, here's how we would break it down. We would break it down piece by piece here. Okay? So, this top dot, the 2 lines represent 5s, and the 4 dots represent 1s. So 2 5s and 4 1s represents a 14. The coin-looking circle here represents 0. 2 dots and a line is 5 plus 2, which is 7. 2 lines is 5 plus an additional 2 is 12. Now we take those Hindu-Arabic variables or numbers here, and we want to multiply them by the place value given. Remember, the bottom place value here is 1. The next place value is 20. The place value after that follows the previous slide. 18 times 20, which is your 360. And then 18 times 20 squared, which is your 7,200. That's how they're getting these values here. So this is essentially 18 times 20. That's how we got the 360. And this is 18 times 20 squared. That's how we got the 7,200. But we also have to multiply that by the Hindu-Arabic variable that we got from the lines and the dots here. What we see now is that first one, when we multiply it out, is 100,800. The second one is 0, because anything times 0 is 0. The next one is 140, and the following one is 12. We add all those together, and we see that our Hindu-Arabic numeral for this Mayan number here is 100,952. That concludes the brief lecture on numeration systems. You will have some practice on this in your homework. It's a fun topic to explore. It does take a little work to work through these different symbols we're not used to. Please take your time. Take advantage of the multiple opportunities to do and practice these on the homework. And perhaps you will be able to go forward in life with some new knowledge of numeral systems from the past. I hope you enjoyed the lecture. I look forward to seeing you next time. Please attempt your homework. If you have any questions, don't hesitate to email me. Have a good afternoon.